Welcome everybody. I'm Doreen Weinberger and we're here today to have fun with liquid nitrogen. So I don't know how many of you know what liquid nitrogen is. Anybody? Oh, come on, you guys. Anybody else? Okay, I'm sorry, I don't know you. What is liquid nitrogen? Did you read? It's basically air. It's air that's cooled down to such a low temperature, about 77 or 78 degrees above absolute zero, that it becomes liquid. And we have a vast supply of it over in Save and Read, and we've brought some here today. So we'll do a number of things. And Nalini's going to be the other mad scientist here who will help out, right? And so here it is. Whoa, and my goggles are just not working. So as you can see, when you pour it, that's right, it's the coldest stuff you've ever seen in your life. 77 degrees or so above absolute zero. I think that's about it. Okay, we need more. I can tell that. We'll leave that for the moment. And you can hear the poor thermos cracking and as it's cooled to that extremely low temperature. And the first fun thing we'll do is we'll put an object in there, namely ping pong ball. And so your task is to explain what happens and why. I lost it. There it is. Whoa, stay there. Oh.
It happens because they're too slippery.
They're too slippery, right? You know, I hope this is going to, you know what, we're not going to have enough liquid nitrogen with 2 containers, I don't think. No, but that's all right.
Is there another one?
There's another one, but we're going to need, next time we'll need 3. Okay, so I'm immersing the ping pong ball in the liquid nitrogen. Doody-doody-doody-doody. And now we're going to bring it out. Come on, you. Too much friction, yeah. There we go, 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 there we go. Woo! Everybody see what it's doing? Everybody see what it's doing? Spinning like crazy. So your job is to explain that. Oh yeah, we do that one?
Doreen, I think you should put it on the metal ring.
Okay. Woo-hoo, hurry up, get in there. There we go. That's a great idea. So there you have it. So can anybody explain that? Air. It's like something you've seen before, but in a different context of sort of lifting off vertically. Anybody know? What happens? There's a small hole in the ping pong ball. There's a small hole, and what does that mean about the air inside? Initially, the air collapses. What am I trying to say? Compresses. Liquid nitrogen can even get in. Okay. And then when you bring the ball out, what happens to the air? And liquid nitrogen is basically liquid air. What happens to that air when you bring it outside to sort of room temperature? It expands. It's ejected out the hole, which is kind of made with a little needle parallel to the surface of the ping pong ball, and it's ejected out in a direction along the surface, and it makes the ping pong ball spin, as you saw. So I cheated. I didn't tell you there was a hole in the ball. Okay. Do we want to break a banana now, or do we want to do the liquid the demo first? No, you do it. Do the thunder. Okay. All right. So we will do the. So we will now show you thunder. Does anybody know what thunder is? Caused by? Thunder, lightning. What's thunder caused by? Yeah, that's on the right track, definitely. What happens when lightning travels, actually a lot of times lightning travels up from the ground to the cloud, but does anybody know what happens to the air when lightning occurs? A lightning strike occurs? We have to do this quickly.
Yeah.
Unfortunately. Basically, it's the temperature of a lightning strike going down through the air where that air is pushed out, creating almost like a vacuum. The air is heated so fast and so furiously, it creates like a shock wave, essentially. And it's that superheated air traveling outwards that makes the clap you see. It's just like any kind of an explosion type effect. And there's probably another clap from the air rushing back in as well into that essentially vacuum. So we can't duplicate the temperature of a lightning strike, which is about 50,000 degrees, which is about 10 times the surface of the sun. So we'll start out with very, very, very cold air and bring it down to normal room temperature, actually boiling water is what we're going to use now to superheat that air in liquid form, and you should hear a very similar effect to the lightning. Thunder, excuse me. All right. Do you want to dump one here? Here. Yeah, do you want to do it? Yeah, I don't want you to get splashed. Okay, I'm going to stand up from here though. Okay, ready? 1, 2, 3. I clearly needed a larger, I clearly needed a bigger wetsuit. Now, I was looking right at, all right, okay. And then Leanie will demonstrate the next amazing feature of liquid nitrogen. You're okay, you didn't get splashed, did you? Oh, okay, because I've gotten burned. I've gotten burned from the hot water, so it's happening. What's that? Oh, you're just too far away. You're just too far away. Whenever there's lightning, there is always thunder. Yes, there is always thunder. Always, always. Yeah. That's a really good question. Somehow, it's a pressure, definitely a pressure effect, but I don't know. Do you know how liquid nitrogen is made? I don't really know. They refrigerate it, but I don't know how they refrigerate.
They pump on it.
They pump on it and refrigerate it somehow. But
What was the question?
how they actually make the liquid? How do they take the air or nitrogen and make it
Yeah,
liquid?
I mean, it's essentially the same thing that your air conditioner does. When you take something and you expand it out rapidly, it cools. And then
Pressurize it. You finding it? Because there is another one. There's another one here. Ah, okay. Ready? Yeah, right. Hurry up, it's thawing. Woo! Banana popsicles.
I don't like bananas.
That's pretty much it, folks. 10 minutes of science. You're welcome, you're welcome. Yes, it did. It did.
Hope to see you next week.